Okay, this time we are going to be doing mix both ionic and covalent. So that means before we do anything, we have to determine what kind of compound it is before we name it. And we do that by looking on the periodic table. So make sure you have your periodic table handy as you're doing this worksheet. If we look at the periodic table, we see that sodium is here. That means that it's going to form a cation when it reacts. And then CO3 is a polyatomic anion. Because I can look on the periodic table and determine that sodium is always a +1, I don't need any kind of Roman numerals. And because it's a cation, it's going to be the ionic naming rules. So Na is sodium. Because I don't need any Roman numerals, I'm just going to go ahead and write the anion as well. So it's going to be sodium carbonate. Number 2 is P2O5. Phosphorus is here, and oxygen is here. Notice that when we're looking on the periodic table, they're both nonmetals. That means those electrons are going to be shared, which means that we're going to be using the rules for molecular compound because it forms a covalent compound rather than an ionic. So, when we're doing this, look at what we have first, and then because it's molecular, we're going to be using the prefixes. So 2 is di, so it's diphosphorus. Oxygen becomes oxide because we only want the base of the word. And then 5 is penta. So diphosphorus pentaoxide, we're using prefixes because they're both nonmetals and forming a covalent bond. Looking at the periodic table again. For number 3, we notice that nitrogen's here and hydrogen's here. Even though hydrogen's on the far left, remember that's the one on the left that's actually a nonmetal. So therefore, they're both nonmetals, which means that the electrons are being shared. So we're going to be using the rules for the molecular compounds, for the covalently bonded. Notice that there's only one nitrogen. If the first element is 1, you don't have to write the mono. Mono is only for the second element. Hydrogen is 3, so it's tri, and hydrogen becomes hydride. Looking at the periodic table, we find that Fe is iron, and it's right there. You cannot determine the charge of iron just by simply looking on the periodic table. That means that I'm going to be needing a Roman numeral here. Also notice that it's a metal. The fact that it's a metal means that we're going to be using the rules for ionic naming, not covalent naming. So it's ionic naming. So that means it's going to be, we're not using the prefixes because it's ionic. SO4 is sulfate. I'm going to put SO4 in parentheses so that way I don't mix up that 4. That 4 stays with the oxygen. That does not get uncrossed. So iron's a +1, sulfate's a -1. When you look at the charge of what the anion's supposed to be, what sulfate's supposed to be, it's supposed to be a -2. So that means I have to multiply both of these by 2 in order for that sulfate to be -2. That means our iron is actually iron 2 sulfate. Okay, silicon. Silicon is right here, and it's going to behave as a nonmetal in this circumstance. So we have silicon oxygen. We have 2 nonmetals. That means that they are going to form covalent bonds, which means we're going to use the naming rules for molecular, which means we're going to use prefixes. So nonmetal and nonmetal, remember we're going to be using prefixes. So silicon Because the first one's 1, we don't have to put anything there in front of it. We don't have to use a prefix there. And we have 2 oxygen, so it becomes di for 2. And oxygen becomes oxide. Okay. Get the periodic table. Gallium is right here somewhere, approximately. And chlorine is right here. Gallium is going to behave as a metal this time, because it's on the left of the squiggly line. That means we have to use the rules for ionic. So that means there are no prefixes. We're going to be using the crisscross. Now, because of the fact that I can look on the periodic table and realize that gallium is a +3, I don't need any kind of Roman numerals there. I can just go ahead and write the anion. That becomes gallium chloride. Cobalt is right here, while bromine is over here. We have a metal with a nonmetal, so that means we will not be using prefixes. We'll just be writing the anion and cation, or cation and anion. I cannot determine the charge of cobalt by looking at the periodic table. That means I'm going to need a space there for the Roman numerals. And then I have bromide. To get that Roman numeral, I need to uncross it. I look on the periodic table and I realize that bromine is supposed to be a -1, so that's correct. So that means cobalt must be a +2. I don't have to change anything. Alright. Boron and hydrogen. Boron is here. Hydrogen's over here. Remember, hydrogen is still a non-metal even though it's on the left side. So that means we have non-metal bonded to a non-metal, which means we have molecular, which means that we're going to be using prefixes. So we have 2 borons, so that becomes diboron, because di is a prefix for boron. 4 is tetra, and we're looking at hydrogen, so that becomes tetrahydride. Number 9. Carbon is here, oxygen is here. They're both nonmetals, which means that it's going to be a covalent bonding because the electrons are going to be shared. It's going to be molecular, which means we're going to be using prefixes. The first one is 1, so I don't have to write mono. I don't have to write a prefix for that. The second one is 1, but I do have to write mono for that one because it's only the first one that has the exception. Then it's oxygen, so it's oxide. So it's carbon monoxide. Alright, and the last one. Technically, P4 is just simply phosphorus. Because in nature, you'll find phosphorus as P4, not just P. However, if you put tetraphosphorus, I would have been okay with that as well. Alright, and that is 1 through 10 for this worksheet, and we will reverse the process for 11 through 20 on the next video.